Right, so let's look at finding square roots. For finding square roots, I'd rather show you and have you kind of explore this with me. If I give you the definition, which is a number that when multiplied by itself gives the given number, so let's just not worry about the literal definition. Let me just show you what it looks like. So square root looks like this. It will be a check mark with like a line above the top, and the inside number x will be a given value, a specific number. So let me give you an example. Say I ask you for the square root of 9. That square root of 9 means this is what you're thinking. What number to the second power, or times itself, gives me 9? So if you can think of what number times itself gives you 9, that number would be 3 to the second power is 9. So therefore, answering the question, what number multiplied by itself gives you 9? The answer is 3. Another quick example. See if you can do this one before I tell you. So what do you think the square root of 25 is? You should have been thinking, what number times itself, or to the second power, gives me the answer of 25? And then you should have concluded 5 to the second power gives me 25. 5 times itself is 25. So therefore, the square root of 25 is 5. So to put that into words, it's easier just to show you. So let me just write the list of all of these numbers that will do this. So if you have 4, then you have 9, 16, 25, 36, 49, 64, 81, and 100. What do all these numbers have in common? These are all the numbers that you get when you multiply a number by itself. Okay? And this is very, very, very special list of numbers. These are called perfect squares. That's 2 squared. That one is 3 squared. That one's 4 squared, 5 squared, 6 squared, 7, 8 times 8, 9 times 9, and 10 times 10. These are called perfect squares. Okay, now, why are these perfect squares so important? And what do you think of when you hear the words perfect squares? All right, and in talking about these perfect squares, I want to show you what exactly that means visually. So let's just assume I pick up 16 tiles from Home Depot and I'm going to lay them out on the floor and I want to create a square. That means my square would be 4 by 4. So I would lay out my tiles in such a way that I would lay 4 across this way, and it would create a 4 by 4, which would complete all of my 16 tiles. If I would have accidentally picked up 15 tiles, I would have had a hole here in the corner. It wouldn't be a complete square. If I would have picked up 8 tiles, it wouldn't have been a complete square. If I would have picked up 17 tiles, I would have had to put an extra tile here. I wouldn't know how to fill in these rest of them. I would need to go purchase more. And if I were to purchase the rest of these tiles, that would be 1, 2, 3, 4, 5. That would be 20 tiles. Could I create a perfect square with 20 tiles? And the answer is no. You can take these and put them over here, but then it'd be a rectangle length going longer this way. Or you can put 2 of them here and 2 of them here, but then you'd have all this gap here. So the reality is the only numbers where you can actually create perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, and 100. Those are considered perfect squares because you could actually build and create a perfect square with those number of tiles, imagining you putting them in a square shape, okay? So this shows you what the dimensions would be. It would be a 10 by 10, a 9 by 9, an 8 by 8. So this square root stuff could actually have a visual interpretation if you really think about it. So if you have 25 tiles, what would be the length and width? 5 by 5. If you had 9 tiles to create a square, what would be the length and width? A 3 by 3. Okay, so if you're visual, that would be another way to think about it. All right, so let's look at example 1. And it's asking you to find the 2 square roots of 49. All right, so it doesn't have the symbol of the square root. It's given to us in words to find the 2 square roots of 49. So the solution would be, now we're given that there's 2 answers that make this happen. One number to the second power is 49, and there's another number to the second power that also equals 49. Our job is to find which are those 2 numbers. So can you think of a number times itself that you know will equal 49? And you should have been thinking 7. 7 to the second power is 49. And then you have another number to the second power is also 49. Since we already have 7 here as our answer, what other number could it be? Well, I'll give you a hint. Positive 7 times positive 7 is 49. What do you get when you multiply a negative with a negative? Don't you also get a positive? So in this case, we can say negative 7 times negative 7 still gives us 49. So therefore, the other number would have been negative 7. All right? So there you go. 2 numbers that when you take them to the second power or multiply them by themselves, you get 49, which makes them the square root. All right, so let's look at example 2. Find the square roots. So first one, we'll make this example 2a. Square root of 25. Example B. The negative square root of 9 over 16. And C. All right. So for each one of these, you still have the same question. What numbers to the second power give us the value inside the square root sign? So for the first one, what number, to the second power equals 25? And you should have been thinking 5 squared equals 25. So my answer is 5. And for the next one, same thing. What number to the second power equals 9 over 16? Now notice this negative is outside the square root sign. So we're going to focus on finding the square root of the numbers inside first. Then we'll just tag along a negative on our answer. And if you're not sure what this is, this means you have a fraction times another fraction gives me 9 over 16. So what fraction to the second power gives me 9 over 16? Looks complicated, but it's very simple. First fraction times a second fraction equals 9 over 16. Well, if you recall, when you multiply fractions, you just go straight across. So what 2 numerators are multiplied, remember they have to be the exact same number twice, gives you 9. And in that case, you should have been thinking 3. 3 to the second power is 9. And then in the denominator, what 2 numbers times itself same number twice, gives you 16. Should have been thinking 4. So therefore, I can say that 3 over 4 to the second power equals 9 over 16. So then what number to the second power is 9 over 16? 3 over 4. That's the number, when you multiply it by itself, gives you 9 over 16. Okay, simple concept is still there. Although it's a fraction, I know it's a little bit, looks a little more confusing. And now they want, and then we forgot we got to put that negative. Remember, they wanted the negative of whatever this answer was. So we're putting the negative of whatever our answer was. Negative 3/4. And for C, they want us to see that it also works with decimals. So if you think of this as, again, what number to the second power is going to be 2.25? And I have already memorized some of my second powers, and I know that 15 times 15 is 225. So those digits kind of look familiar to me already. If not, then you would just pick up a calculator, no big deal, and you would say, what number to the second power is, in my case, 225. I try to ignore the decimal, and I know it's 15, so therefore I'm going to conclude 1.5. Since it's got a decimal, I'm going to put a decimal in my 15, equals 2.25. So 1.5 times 1.5 is equal to 2.25. And so therefore, what number to the second power is 2.25? 1.5. And notice, after we calculated our square root, they want the positive and the negative number. So we're going to say positive 1.5 and negative 1.5. Which brings me back to this question up here. Instead of writing them separate, that's kind of just like a shortcut way of saying your final answer would be positive and negative 7. This is very often used when you know that you have a positive and a negative of the same digit. Instead of writing it in two separate ways, you would use plus and minus. So in this case, they're telling me they want the positive answer and the negative answer, just like they did in example 1. So I can just put plus and negative 1.5. Right, so before we get to example 3, I want you to recall something. And recall a skill that I know you already have. If I ask you, for example, what is 5 parentheses with the 2 inside? What does that mean? What would you do? How would you calculate this? And I'm hoping that you were thinking 5 times 2, right? Because you knew that 5 next to a number in a parenthesis means multiplication. And it's invisible, can't tell, but you know that when it's next to it, it means multiply. So in that case, parentheses are grouping symbols, okay? And we have, as we go further along in math, you're going to have different types of grouping symbols. And the new one that we're going to look at today is the square root. So in the future, if you see 5 with the square root, let's say of 4, you might not know what that means or what is it telling me. But you do recall that now this square root symbol is considered one of our grouping symbols, just like the parentheses was. So if you have 5 times 2 here, you know it means multiply, then that's what it means here too. It means 5 times the square root of 4. Right? So just wanted you to recall that you already know what it means when there's a number next to a grouping symbol, multiply. Then don't be surprised when you see 5 next to this new grouping symbol. It also means multiply. Okay? So let's look at example 3 now. And it's going to be 5 square root of 36 plus 7. All right? And then we also have b, and b is going to be 1/4 plus the square root of 18 over 2. All right, So, looking at this problem, I see a number next to a grouping symbol, so I know that means multiply. And now I ask myself, what is the square root of 36? Grouping symbols first. We got to do that operation first. And I know that the square root of 36 means what number times itself is 36? And that answer is 6. Once you've evaluated the square root, you do not need to put the square root back on. We've already answered the question, and that answer is 6. So now we can go ahead and finish the rest. That makes this 30 plus 7 for a total answer of 37. All right, let's look at the next one. Again, order of operations, grouping symbols first. This is considered a grouping symbol. Could I divide 18 by 2? I could divide 18 by 2. That's 9. And you can go ahead and simplify and do the math in the grouping symbols just as if it was a parenthesis. Now, I want to recall really quick back to this example. The reason why I didn't simplify this, because 9 over 16 is not going to be a whole number, and I can't simplify that into an easier, simpler number. So that's why I went ahead and dealt with the 9 and 16 the way it is. But over here, if you could make 18 over 2 into a simpler value, then go ahead and do that. So now that I did my grouping symbols first, I didn't take the square root yet. I just simplified what was inside. Okay, I have not answered the question yet, what number to the second power is 18 over 2? I just rewrote this 18 over 2 as 9. And now I'm ready to ask that question. What number to the second power is 9? And that answer is 3. So now you just have 1/4 plus 3, which is 3 1/4. All right, so let's look at example C. And example C includes something that I wanted to mention earlier, but maybe you'll catch it, and then I'll discuss it after. And it says it's the square root of 81 raised to the second power. So what this means is they want us to first find the square root, then raise it to the second power, because remember, we're going to do parentheses first. What's inside the parentheses? This square root question. So that square root question is asking, what number to the second power is equal to 81? And that number is 9. Because 9 squared is 81. So the question to this problem was, if you think of a number times itself that gives you 81, the answer is 9. Okay, so now I answered this question and the answer is 9. I still have to raise it to the second power. And 9 times 9 is 81. Now this looks a little strange because you're thinking we started with 81. How did that happen? Well, this is something that I did want to mention to you. That anytime you have any number, you're taking the square root of it, and then you raise it back to the second power, you're going to get back that original value. And the same is true for the other way around. If you have a number raised to the second power, and you take the square root of that, you will also get back to the original number. So this is a very important relationship between square roots and second powers, because this concept, we kind of already saw it before. Okay? When you had x plus 2, and we ended up doing minus 2, you got x back. When you had x times 2, and then you divided by 2, you got x back. When you started with x, and you divided it by 2, and then you multiplied it by 2, you got x back. These were called inverse operations. If you had x, and you took away 2, and then you added 2 again, you got x back. So these are all inverse operations. When you add and then you subtract, those are inverse operations. When you multiply and then you divide, those are inverse operations. So what I'm now showing you is a new set of inverse operations. The inverse operation of a square root is taking it to the second power. The inverse operation of a second power is taking the square root, and you get x back. So, if you really want to think about it, multiplication and division were inverses. Addition and subtraction were inverses. And square roots and second powers are also going to be our new pair of inverse operations, which is pretty cool. So, there you go.